my dear student, I'm Mr. Actuala from Educators. I will be with you in physics for Form 5. And today we are going to proceed with our discussion on our topic of fluid dynamics for our subtopic of the viscosity and the turbulent flow. So welcome again for our discussion, my lovely student here. But before we proceed with our discussion, we are supposed to understand where we ended on the last session. On the last session, we tried to see the Poiseuille's formula. And we said that Poiseuille's theorem explains about the volume flow rate. How can it be related with the pressure gradient? How can it be related with the coefficient of viscosity? How can it be related with the distance of the tube or the radius of the tube? This is what we tried to see on the last discussion. And we demonstrated the formula related with the Poiseuille's theorem, which said that the volume flow rate must be equals the volume flow rate must be equals to the pressure. It must be equals to K. It means K alafu kuna pressure times the A power 4. Then we divide him by the coefficient of viscosity times L. Lakini tukasema kwamba ile K anakuwa ni sawa na constant ambayo ni sawa na pi power 8, and we demonstrated by saying that therefore we should express the volume flow rate by taking a pi times the pressure times the radius power 4, then we divide by 8 coefficient of viscosity times L. And we explained more that imagine we want to determine the viscosity of the fluid or the viscosity of the liquid in a YouTube. Tumejaribu kuangalia pale tukapata kasa kwamba we should express the pressure in terms of the density and also the height. Kwa tukasubstitute, kumbe sasa general formula ambayo tutakuwa tunaitumia kuweza kutafuta volume flow rate must be equals to pi alafu density times the hg, then we times by the a power 4, we divide by 80 coefficient of viscosity times L. This is what we demonstrated on the last session. But on our today discussion here, we are going to see some examples related with what we learned on the last sessions. So we have our example number 5.4. This is our example number 5.4. And our example said that, my dear students, water flows through a horizontal tube with the diameter of 0.08 meter and a 4 kilometer length at the rate of 20 liter per second. That we have the horizontal tube, and that horizontal tube containing the amount of water. That water, my dear student, flows through the horizontal tube, where the tube having the diameter of 0.08. It flow at the length of 4 kilometer. Kwa haya maji yaliweza kutiririka horizontally katika kilomita 4. Kilomita 4 ni kaumbali kabisa, ndio yalivyokuwa yana move horizontally. Lakini yalitengeneza volume flow rate. It means the volume flow rate ambayo ilikuwa ni sawa na 20 liter per second. This is what we have been given into our equations. So calculate the pressure difference required to maintain the flow given that the coefficient of the viscosity of water is 10 exponent negative 3. Kwa tumeambiwa tuweze kutafuta yule pressure difference ambaye atahitajika kuweza kumaintain ile flow. Tunataka kwamba ile flow iendelee. It means kwamba the liquid to continue flowing, the water to continue flowing, we must have the pressure ambao ita exert at the one end and also at the other end. Kwa lazima tuweze kudetermine the pressure difference. This is what we have been asked on our equation here. So given that the coefficient of viscosity of water is equal to this one, but we have been given the coefficient of viscosity of water which is equal to 10 exponent negative 3 NSM per second square. NS per meter square as we observe here. But assume that only viscous resist exist, lakini tutakuwa tuweze kuassume kwamba hii viscous exist. Means unapokuwa tunazungumzia viscous, it means kwamba we talk about the internal friction that occur between the layer of the fluid. This is what we have been asked on our equation here. Now, how can we identify, how can we calculate the pressure difference required to maintain the flow? Kwa tunapataje ile pressure difference required to maintain the flow rate? This is what we are going to see on our discussion here, my lovely students. So as we see that before we go and answer this question, we are supposed to summarize the data that we have been given. So on our question here, we have the diameter, which is equal to 0.08 meter. And also we have the length of the horizontal pipe, which is equal to 80 kilometer. Now we are supposed to convert that length into the meter. Kwa tutajaribu kuibadilisha kuipeleka kwenye meter. Also we have the volume flow rate, which is equal to 20 liter per second. Kwa tumepewa na hii volume flow rate. Also we have been given the coefficient of viscosity ambayo ni sasa na 10 exponent -3 kilogram per meter second. This is what we have been given on our question. How can we get the pressure difference? So let us go and see the equation here, the way we can answer these equations. So my lovely student here, we are supposed to recall the post-series theorems. According with the data that we have been given on our equation here, let us recall the post-series formula, ambayo anasema kwamba rate of flow of the volume must be equals to the pi alafu p a power 4 divided by 8 coefficient of viscosity times the length. Kwa tuweze kurecall hiyo formula kwa sababu ya data tulizopewa pale kwenye swali. Tumepewa diameter, tumepewa diameter, pia tumepewa length, tumepewa yule coefficient of viscosity. Kwa tutaweza kurecall hapa ili tuweze kutafuta pressure ambayo tumeulizwa. So how can we get the pressure difference that we have been asked? So we get the pressure difference, my dear student, here is by calling the post-series. Now from our formula of post-series theorems, let us make P at the subject that imply the pressure difference. Kwa tunatakiwa tuweze kumake at the subject. If we make it at the subject, we should obtain that the pressure difference must be equals to V divided by T. Then we multiply by the 80 coefficient of viscosity times the length we divide by pi a power 4. This is how we determine the formula of the pressure. We use the concept of the transposition, the way we can create the new formula by using the expression that will be given on our equations. That is what we are going to see how can we demonstrate. So the pressure P must be equal to V over 8. As I told you that use this relationship to make it at the subject. If you make it at the subject, you could obtain that pressure must be equal to the volume flow rate times the 80 coefficient of viscosity times the length divided by pi a power 4, as we try to demonstrate. So after this one, let us go and substitute the value that we have been given into our equation. Because on our equation here, we have the diameter that is 0.08 meter. Also, we have the length at the rate of flow, the length at the rate flow, ambayo ni exactly at the length flow, ambayo tumepewa ni sawa na 4 kilometer. Now we are supposed to convert this length into meter, ambayo atakuwa ni 4 exponent 3. Lakini tumepewa huyu volume ambayo yupo kwenye lita, alipo kwenye lita per second. Tunatakiwa tumbadilishe kwenye lita tumpeleke kwenye mita, atakuwa ni 8, atakuwa ni sawa na 2 exponent -2. So as we observe, my dear student, if we substitute our given values, because the A we have, the A is equal to the diameter, ambao tumeshapewa pale kale ka distance ka tube ni sawasawa na is equal to 0. The A is like the length. The A we have, my dear students. So if we substitute the value that we have on our equation here and take our calculator and substitute those values, we could obtain the pressure difference must be equal to 7.96 exponent 4 Newton per second, Newton per meter square. This is the value of the pressure difference that you could exert on the horizontal pipe located at the diameter, which having the diameter of 0.8 meter and also the distance of 4, as we tried to see. As we see that here the diameter that we have been given tumeshapewa ni sawasawa na 0.08. Kwa tutakuwa tuiweze kugawanya kwa mbili tuweze kupata huyu A kama tulivyoambiwa pale. Ukimaliza pale utasimplify, mwisho wa siku utaconclude kwa kumwambia the pressure difference must be equal to 7.996 exponent 4 Newton per meter square. So after this one, let us see another example, my dear student, which is the example number 5.5.